Okay, so let's do chapter 7. So matrix is an array of numbers. So array means like rows and rows of numbers. So a matrix is just a bunch of numbers together in one form. So for example, this one, matrix A. Okay, so each matrix has a size, and the size, or we call order and size mean the same thing. The size of this matrix is row by column. Okay, this X here, we don't call times, we say by. So something by something. Okay, so if you look at matrix A, how many rows does it have? Remember, rows goes horizontal. How many rows does it have? Two rows. Oops. 2 rows. How many column? Column goes vertical. 3. So 2 by 3. So you say 2 by 3. The size is 2 by 3, not 2 times 3. Okay, 2 by 3. And the way we number the rows is we name it going down. So row 1 and row 2. So goes top to bottom. Columns go from left to right. So this is column 1, column 2, column 3. All right, let's do a really quick practice. So you're going to figure out the size of the following matrices, 1 and 2. So how many rows, how many columns, what would be the size of the matrix? All right, let's do this. Let's start from Wimbo. Number 1, how many rows does it have?
3.
Okay, Andy, how many columns?
2.
And Cielo, what's the size of the matrix?
3 by 2.
Good. Okay, Shauna, number 2, how many rows?
2.
Sophie, how many columns? 1. And then Bruno, what's the size?
2 by 1.
2 by 1. Good. All right. Now let's look at matrix element. Element is something inside the matrix. So it's a number inside the matrix. We're now talking about the specific numbers that's in the matrix. It is also defined by row and column. But we don't use capital letters anymore. We use lowercase letters. So for example, A12. A12 is an element that's inside the matrix, and 1, 2 means row 1, column 2. So this 1, the first number is the row, and then the second number is the column. So for example, if you look at this matrix is a 3 by 3 matrix because 3 rows and 3 columns. And you can see that the first number here on the top left is A11. 11 means first row, first column. Oh, first row, first column. Okay, A12 means first row, second column. What do you think the next one is going to say? A13, because first row, third column. What about this one? The second, this one here, without giving to A21. Okay, second row, first column. Okay, so go ahead and figure out the rest of these. So just write all of those element numbers in. All right, everybody's good? Okay, so A22, A23, A31, A32, A33. So easy stuff. Now let's practice what we just watched in the video. You're going to add them together, subtract them, and multiply them by a scalar. So I think you guys can do these on your own. So go ahead and do 1, 2, 3. When you're done, please let me know. All right, number 1. Add them together, -1, 4, 10, 2, -4, 3. Number 2, A minus B. 5, 2, negative 2, negative 2, 2, negative 11. And number 3, 2a. So you're going to multiply every element by 2. 4, 6, 8, 0, negative 2, negative 8. All right, let's talk about some very more, I guess, different things. Zero matrix. Zero matrix is a matrix with all zeros, obviously. So zero matrix, for example, a 2 by 2 zero matrix is just a 2 by 2 matrix with all zeros. Easy stuff. Additive identity. So this is a property that you learned in algebra. So that says 5 plus 0 is equal to 5. So anything plus 0 is just itself back. It's called the additive identity. It also applies to matrices. So a matrix plus the zero matrix will just give you the matrix back. Okay, so obviously it's very intuitive. Now let me ask you, 5 plus what is 0? Negative 5. So you add what to itself? Inverse, or the opposite, right? So if a plus b is equal to 0, what does that mean about b? The opposite, right? So everything in b is the opposite of a. That's how you're going to get 0. So for example, if you get 1, 2, 3, 4, if that is matrix A plus matrix B, gives you the 0 matrix. What must be in matrix B? Yeah, negative 1, negative 2, negative 3, negative 4. Because it has to be the exact opposite to get zeros, right? Okay, very intuitive, but it's just, we'll probably use that property later on. All right, now that was adding and subtracting and multiplying by scalar. Now we're going to multiply matrices together. Okay, all right, so this is where you have to follow what I say. Okay, so last year I trained you guys to follow exactly what I say. Hopefully this year you're not going to do something different. Okay, all right, we're going to multiply A and B together. The order matters. A has to be on the left. B has to be on the right. If you switch and do BA, your answer will be totally wrong. Okay, order matters. So what you're going to do is A, you're going to put on the bottom left. B, just like the video, you're going to shift it up a little bit. Okay, A is on the bottom left. B is a little bit to the top. Next, you're going to draw a matrix like this. This is going to be the final matrix. And then you're going to draw some grid lines. The grid lines are going to go in between the rows and the columns. You already finished? Oh, you're already done. Okay, next, we're going to multiply some elements together. So we're going to use some guidelines. So this row is going to multiply by this column, and the final answer is going to go into where the two lines intersect. All right, so what are the numbers? The first element, 2 times 1, 2. Okay, so 2 times 1, that gives you 2. And then you're going to take the next one. 1 times 0 gives you 0, so that goes here. And then you're going to take the third one. Negative 3 times 1. That's negative 3. And then we're going to add all of them together. And that goes in here. Good? How many people remember this from last year? Okay, half. Okay. All right, now you're going to do the same thing with the next one. So this row again with this column, and that's going to go into that number over there. Good? All right. Once you get the whole matrix, please let me know so I can double check your numbers. Negative 1, Negative 6, 2, 2. All right, so be careful with your signs. Next, let's do it the other way. Or actually, never mind. Let's do AB. All right, so let's also multiply this. A times B. Okay, so let's have everybody try it. A times B and see what you get. Remember, A has to be on the bottom left, and then B has to be on the top right. A goes on the bottom left. B goes on the top right. Okay, so let's multiply this row by this column. So you can see that I'm going to multiply 2 and 3 together plus 1 times 2, but this negative 3 has no partner to multiply. So this one you cannot multiply. Now, you don't really want to set it up and realize you cannot multiply. There's a way to check before you even try multiplying it. Okay, so you can only multiply the matrices if A has the size of, let's say, M times R or M by R, and B has the size of R by N, and you can only multiply them if the two in the middle are exactly the same. Okay, you can multiply A and B together if A is M by R, B is R by N, and those two in the middle have to be exactly the same. They have to be the same number so that you can multiply. So for example, if we look at the one that we just finished, what is the size of A? The example we just finished. What's the size of A?
2 by 3.
2 by 3. What is the size of B?
2 by 2.
2 by 2. Okay, you can see that the two numbers in the middle are not the same, and that is why you cannot multiply. Good? Okay, so just kind of review from last year. Now, let's say that you can multiply. You multiply them together. For example, this one here, M by R, R by N. The final size of AB. The final size of AB is M by N, the two on the outside. Okay, so you can only multiply them together if the two numbers in the middle are exactly the same. If you do multiply them together, the size is the two numbers on the outside. All right, let's practice. All right, matrix A. Let's just call somebody Raymond Kim. What's the size of A? 2 by 2. 2 by 2. Gary, what's the size of B?
3 by 3.
Oh, not 3 by 2. 2 by 3. Okay, so Murphy, can we multiply them?
Yeah.
Yes, because the two numbers in the middle are the same. Okay? All right, so go ahead and multiply A and B and let me know when you have the answer. The answer is 22, 2, negative 10, 31, 5, negative 7. Now let's talk about identity matrix. Identity matrix is a special kind of matrix where, first of all, it's a square matrix. Second, there is this diagonal that has all ones. So this is 1, and then everything else is all 0. And then the second row, starts with 0, and then 1, and then 0 all the way down. The third row is the same, 0, 0, 1, and then everything else is 0. And then it turns out that the whole diagonal is all ones. And then everything else is 0. So basically, an identity matrix has to be a square matrix. Okay, square matrix means like 2 by 2, 3 by 3, 4 by 4. And then the diagonal is all ones, and then everything else is 0. All right, why do we have an identity matrix? Because it's helpful in multiplication. So just like the zero matrix is helpful in addition, we need an identity matrix in multiplication. So any matrix times the identity matrix will just get the matrix back. And it doesn't matter which direction you multiply. You would just get the matrix back. The reason we want to talk about identity matrix is because we need to use it in inverse matrix. Okay, so for example, if we have two matrices, A and B, we multiply them together and then we get the identity matrix. I is always identity matrix. If we get the identity matrix, then B must be the inverse of A. Because the only way we can get the inverse, the identity matrix is when we multiply the matrix and the inverse. That will give us an identity matrix. Okay, so for example, like let's talk about like numbers. You know, you guys are better with numbers. So 5 times what is gonna give you 1? 1 over 5. So what's the relationship between 5 and 1/5? They're reciprocal, which in the inverse, the matrix world, we call that inverse. Okay, so same thing applies. A times something gives me the identity matrix, then that something has to be the inverse. Okay, so kind of like numbers. While not every matrix has an inverse. If a matrix has an inverse, we call that non-singular. So this is where you got a lot of vocab. You got to kind of highlight or something to make sure you memorize them. If a matrix has an inverse, we call that non-singular. If a matrix has no inverse, we call that singular. All right, really quickly, let's check. How can we tell if A and B are inverses of each other? Someone said something. Huh? Yes, multiply them. And what are you looking for?
The diagonal row of ones and the rest are zeros.
Yes. Because if A and B are inverse of each other, then when you multiply A and B together, you're supposed to get I. Okay, so try it. Multiply them together, do you get the identity matrix? So A times B, did you guys get 1001? Yeah, so what does that mean about A and B? They're inverse of each other. Okay, so B is the inverse of A and A is the inverse of B. All right, so that's how you check. Of course, I'm going to teach you a different way to check tomorrow, but for now, just multiply them together. Now, let's do another one. Prove that this matrix is singular. What does singular mean?
Doesn't have an inverse.
No inverse. Yeah, so we had to prove that it has no inverse. How do we prove that there's no inverse? How do we show that this matrix cannot have an inverse?
Do you multiply by the identity?
If you multiply by identity, remember you're just going to get the same matrix back.
Right.
Has no inverse. Any thoughts? No? What happens if it has an inverse? Silence. No?
We try to make it the
Yes. So if there is an inverse, then this matrix times something, some matrix, we should get I back, right? Maybe we can try to find that matrix? No? Oh, okay. All right. Answer tomorrow.